Hi guys, welcome to a new video on differentiation under math studies. This video deals with level 4 difficulty questions, which is an upper intermediate level of difficulty. I shall solve the two questions on the screen in front of you, and I shall begin with the first question shortly. I shall now attempt to solve May 2012 times 1 question 5. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So in question A, you are required to sketch the graph of the given function, and you are given the window settings that you need to use. You should show clearly the axes intercepts and the maximum and minimum points, and you are given the scale to use on your graph paper. So I shall write the equation down on my GDC. So there is my equation, and I've adjusted the window according to the question, and there is what the graph should look like. You can tell from the graph that the y-intercept exists at -3 and the x-intercept exists roughly around x equals 3, and you should show the minimum point and the maximum point, which is also the x-intercept. This is the marking scheme version of the graph. You are awarded 1 mark for the window and the labels, a mark for a smooth curve, and a mark for the x and y intercepts. Finally, a mark for the local maximum and minimum points. The minimum point should be between 0 and 1, and -2 less than y less than -4. And the y coordinate of the maximum point should be 0 plus or minus 0.5. So preferably 0 at the x-axis. If you are off by 0.5, you do not lose marks. Next, you are required to find the value of f of -1. So second trace value, and I enter -1, and the y value is 0. So f of -1 equals 0. Next, I need to write down the coordinates of the y-intercept of the graph. You can do this using the GDC, or you simply realize that the y-intercept exists when x equals 0. So any term that has an x in the function shall disappear. So this is crossed out, this is crossed out, this is crossed out as well. So all that remains is the -3. Hence the coordinates are 0, -3. And next you are required to find f dash of x. So let's take a look. So there is your original function in black, and there is the derivative function in green right there. This is your derivative function. Now in question E, you are required to show that f dash of -1 is -16/3. So unfortunately, since you are already given the answer, you cannot just use the GDC function in order to find the slope at -1. You have to do it manually here. So I simply substitute x for -1, and instead of this x I have a -1 right there. Similarly for this x, and the answer does in fact turn out to be -16/3. You are required in F to explain what f dash of -1 represents. F dash of -1 represents the slope of the tangent line at the point x equals -1, or f dash of -1 represents the slope of the curve at x equals -1. both of these answers work. In G, I'm required to find the equation of the tangent to the graph of f of x at the point where x is -1. So the equation of the tangent requires two things, a slope and a point. So the slope I already know from E. The slope at -1 is -16/3. And the point is the point where x is -1, but I need the y value. Thankfully in B I was required to get the y value, which is f of -1. So I have everything I need to write the equation down. I just need to substitute into the point slope formula. So there is my slope, there is my point, -1 and f of -1, which I know from B, is 0. Hence my point is -1, 0. So I plug into the point slope formula, and this is the final equation that I get. So in H, I'm required to sketch the tangent to the graph of f at x equals -1. So I just need to write the equation down on the GDC. So I've changed my equation a little bit. I've just expanded this bracket in order to have an equation that I can write down on my GDC. I've written the equation down and then I click on trace. So this is what the tangent should look like, and you copy this down on your sketch, and we can see that the marking scheme looks like what we have on the GDC. Of course, you didn't even have to sketch it on your GDC. You could have just drawn a line that touches the curve at x equals -1. However, if you were unsure of what to do, you could just simply write the equation down on the GDC and let the GDC sketch for you. P and Q are points on the curve such that the tangents to the curve at these points are horizontal. The x-coordinate of P is A and the x-coordinate of Q is B. B is greater than A. Find A and B. So the points where the tangents are horizontal are the turning points. So this point right there, which is the minimum point, and this point right there, which is the maximum point. These are the points where the tangent is horizontal. So the tangent has zero slope, or the tangent is horizontal, or f dash of x equals 0. All of these are words describing local minimum and local maximum points. So I just need to find the x-coordinates of the local minimum and the local maximum, noting that since B is greater than A, so this is A, the minimum is A, and the maximum is B, because B comes after A. So second, trace minimum, and you provide the left bound and the right bound. And the guess. So the minimum lies at x equals 1/3. They just want the x-coordinate. 0.333 is actually 1/3. Next, for the maximum, second, trace maximum, left bound, right bound, and guess. So your maximum lies at x equals 3. Hence A is 1/3 and B is 3. Finally, you are required to describe the behavior of f of x in the region A less than x less than B. So in this region, starting from the minimum and up to the maximum, in the region that lies in between, the function is increasing. This is the behavior of the function. So there are your answers. Take a look at them This concludes our question. I hope you have found this useful. I shall now attempt to solve May 2011 time zone 1 question 3. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So I am given this function f of x equals x cubed plus 48 over x, and in A I'm required to find f of 2. So you can do this manually by plugging 2 instead of x, or using the GDC as I've done here. I've written the function on the GDC. Next I shall adjust my window as follows. Next I shall click on trace, and second trace value x equals 2, y equals 32. Hence when x equals 2, y or f of x equals 32. So f of 2 is 32. Next I am required to sketch the graph of the function. Y equals f of x for negative 5 less than x less than 5 and negative 200 less than y less than 200. So I have to adjust my window on the GDC accordingly. I've plugged the relevant values on my window, and there is my curve, and I need to sketch this curve. Let's check the marking scheme requirements for the sketch. So you get a mark for labels and scales, x-axis, y-axis, and some scaling. You get another mark for the correct shape of two unconnected and smooth branches. So the shape as per your GDC, you just need to copy this down. You get a mark for the maximum and the minimum in approximately correct positions. So again, from the GDC, the maximum here is approximately at negative 2, and the minimum is approximately at 2 or slightly before 2. So you need to make sure this is reflected on your sketch. Finally, you get one mark for asymptotic behavior at y-axis. The curves must approach the y-axis but not touch it at all. And watch out, because they've instructed the examiners here to make sure that you are accurate in your drawing. So the y-axis must be an asymptote for both branches. Neither branch should touch the axis, nor must the curve approach the asymptote then deviate away later. So you cannot approach the y-axis and then drift off with your curve to the right. It has to approach the y-axis and remain close to it but never touching it. Next, in question C, I'm required to find f dash of x. So I've rewritten the original function f of x here. The change that I've made is that instead of having 48 over x, I've written it down as 48x to the power of negative 1. This is simpler to differentiate. Hence the derivative function looks like this, or like this. This is another form of the derivative function that also works. Again, the only difference is here x has a negative exponent, and here x has a positive exponent in the denominator. Both are fine. Next, you are required to find f dash of 2. Now this is interesting. There are two ways to do so, either by plugging 2 into f dash of x or using the GDC. So a nice way to check whether f dash of x is correct or wrong is by doing it both ways and making sure that the answers are the same. So the manual approach is just to replace the x with 2. So you get 3 times 2 cubed minus 48, 3 times 2 squared minus 48 over x squared. 48 over 2 squared. This gives you 12 minus 12, which is 0. So let's check whether this matches the GDC answer or not. The way to do this on the GDC is as follows. Second, trace dy by dx, and you enter the given x value 2, and the calculator tells you that the gradient is a number times 10 to the power of negative 6. So a number times 10 to the power of negative 6 is 0.0000002, for example. So this is the calculator's way of telling you that the answer is 0. It's a very, very, very small number, which means that it's 0. The reason why the calculator doesn't always write 0 has to do with the computer chips inside the calculator. It has nothing to do with you or your exam. So whenever you get such a tiny number, you just understand that the calculator means that the answer is 0. So we confirmed using the GDC that our answer is correct. Next, I'm required to write down the coordinates of the local maximum point on the graph of f. So I can use the GDC to do that, simply because this is a write down question, not a calculate question, and there are only 2 marks given for this. So the maximum point exists somewhere there. So second, trace maximum left bound, right bound, and guess. So the calculator tells us that the maximum point exists at -2 and -32. Of course, this does not mean that this is the absolute maximum point in the graph, because as you can see, this point is higher, but this is what we call a local maximum. Within this region of the graph, this is the maximum point. In the negative region of the graph, this is the maximum point. Similarly, here, this is the local minimum, not the absolute minimum of the graph. Within the positive region of the graph, this is the minimum point. Next, in f, I'm required to find the range of f. So f lies below this value, which I have already found to be -32. Hence, y is less than or equal to -32. And f also lies above this value, which I can find similarly using the GDC, and it is +32. Hence, y is greater than or equal 32 as well. So y is either greater than or equal to 32 or less than or equal -32. And the way I found this minimum point was using the GDC as follows. Second, trace minimum. I provide a left bound and a right bound and a guess, and the calculator tells me that the minimum exists at 2 and 32, which are the coordinates that I've used. Next, I need to find the gradient of the tangent to the graph of f at x equals 1. There is a calculator function to do that. Second, trace dy by dx, and you enter the x value given in the question. So dy by dx, or the gradient, is -45. This is your answer. Finally, you are told that there is a second point on the graph of f at which the tangent is parallel to the tangent at x equals 1. So parallel means they have the same slope. I need to find the x coordinate. So since the lines are parallel, then they have the same slope. Hence, the slope is also -45 as in G. Hence, f dash of x equals negative 45 because this is the equation of the slope, and I solve this equation using the GDC. So what I've done here is I've taken the negative 45 to the other side and it became positive, and I can write this equation down on the GDC and attempt to solve. So I've written the equation on the GDC, and here is what the graph looks like. I want to find the solutions of this equation, which is equal to 0. So I'm looking for the x-intercepts. Of course, I can use the calculator to find them. Second trace 0, and the left bound is somewhere here, the right bound there, and the guess is here. So the first 0 lies at x equals negative 1. Similarly, the second 0 shall be obtained in the same way, left bound, right bound, and guess. So the second 0 lies at x equals 1. Hence these are my two solutions. Since we already know that x equals 1 in the previous question, hence for this line x has to equal the other value, which is negative 1. So take a minute to write the answer down if you will. I hope you have found this useful.